This part of the program is a rubber industry author talk. This is a new addition to the rubber industry news server. The component of rubber industry author talk is basically we invite authors who publish papers in reputed journals or magazines about rubber technology or rubber developments. So we ask them to talk about their published papers. So in this today session, we have Dr. Hiroshi Mouri, retired as a president of the Bridgestone America Center for Research and Technology. He has published a paper on the optimized laboratory test condition to predict tire tread wear. This paper was published in a Rubber World magazine in January 2022. I do encourage all of you to subscribe this Rubber World magazine, one of the best technical magazine. You find a lot of useful information. You go to rubberworld.com, you can subscribe that the magazine, and also you download this paper, which is January 2022, 2 months ago, okay, published in the issue. Okay, let's we talk about this paper. Okay, let me start the presentation on this paper. Hello, Mr. Hiroshi Mouri-san. Welcome to the Rubber Industry Author Talk. Thank you for accepting our invitation to be part of this program on the Rubber Industry Author Talk. Basically, in this Author Talk, we introduce authors who publish papers in our magazines or research journals to talk about their work. So welcome to the this session today.
Okay, thank you.
Thank you very much. So before we get into your paper, what we are going to discuss on the optimized laboratory test condition to predict tire tread wear, I'd like to get to know more about your experience, your background. Can you please share us how was your experience so far?
Okay, thank you for the invitation first. My name is Hiroshi Mouri, and I have a PhD from Tokyo Institute of Technology, and I worked at Bridgestone for 40 years, and 40. Bridgestone is known as the largest tire company in the world, as you may know. And I worked as a scientist for a long time, and at the last work was as a president of the Bridgestone America Center for Research and Technology. That's in the United States. And I retired at the end of 2019, right before the pandemic. My plan was to travel around the world, but obviously I had to change my plans, and I stay home and work as a rubber consultant. That's briefly my background, and I give lectures at universities, and I help university students. I also do work for ISO, the rubber testing, which is TC45.
Yeah.
So that's about my background.
And so you lived in Japan, or you lived in the US, or which places you work in for Bridgestone?
I live in Tokyo, Japan. I moved back in 2014.
I see. And your main research work is as a scientist. What is your role? You work on what kind of activities you do at the Bridgestone?
Well, I worked on all kinds of things, from natural rubber, synthetic rubber, tire rubber, and tire ingredients. Almost everything. 40 years is a long time.
That's right. Yeah. So you covered. You can say they were Mr. Tire Technologist, or you can say encyclopedia on the tire technology from the Bridgestone.
Yeah, walking encyclopedia.
Walking encyclopedia. That's the right word. Thank you. Nice. That's nice to know about you, sir. Thank you for joining. Okay, so today, I'd like to invite you to talk about your paper on the optimized laboratory test condition to predict tire tread wear. please give us, what is the main content of this paper, what is it, advise our readers to what they look for, how it benefits them. Okay, let me open the file for you. Okay. Yes, please go ahead.
Okay, the title of my talk or my paper is Optimized Laboratory Test Condition to Predict Tire Tread Wear. And this paper was first published in a Japanese paper, Nippon Gomu Kyokaishi, and 4 months later it was published in Rubber World early this year. Next slide, please. Oh, I have the control. Okay, so I'll talk about history. Laboratory tread wear test was developed almost a century ago by Leonardo Lamborn, and known as the Lamborn abrasion test. And you have a test wheel, which is a rubber sample. You rotate it against the abrasive wheel at a different speed. And you can see a decent correlation between tire wear resistance and laboratory wear test result. But this is fourfold difference, and practically when you want to see 20–30% difference, you might want a better prediction. So the next slide is about the changing wear mechanism. Well, 100 years is a long time, and there was a lot of change in the world. Of course, the vehicles were nicer, and they were lighter and have better performance and better alignment, and roads are a lot smoother. The tires were significantly improved too, from bias tire to a radial tire. So there's a lot of changing wear mechanism. Wear mechanism used to be elastic wear, where you see a wear pattern that is perpendicular to the direction of traveling. As you go to milder wear, the abrasion pattern gets smaller. And this is called elastic wear, but eventually this wear pattern gets so small that you can't see it. It disappears. And Alan Wiest of Goodrich, he called this a plastic wear or P-wear. So how do we test this low severity wear? Next slide. We use the FPS wear tester model AB 2012 by Ueshima. And this machine is specially designed to fit the needs for low slip ratio test, low severity test. So the repeatability is within 5%, and this is the most important aspect of low severity testing, because a small change in slip ratio can change the results significantly. And also this has a semi-automatic system, and I want to show you a short video. So since the machine automatically changes the sample, you don't need to be with the machine all the time. You just load samples, push the button, go home, and come back the next day, and you have the test results. And here the wear test begins. And it ends automatically. So this is a brief explanation of the tester. And how do we determine the slip ratio of a low severity test? This is an acceleration distribution of a vehicle. the right side is deceleration, as in the left side is acceleration. You see a big peak right around 0, and this is due to constant speed driving or due to tire rolling resistance. You see a second peak around 0.4 G. This is due to braking, and this is the main driver for wear. This big peak around 0 does not contribute to wear at all. So 0.4 G deceleration is equivalent to a friction coefficient of 0.4, the same thing. So if you look at 0.4 friction coefficient on a slip ratio versus friction coefficient relationship, you see the slip ratio is %. We can skip this one. It's in the paper. So the last slide is optimum laboratory wear condition for passenger tires. Load is about 10 to 15 Newton. Slip ratio, as I show, was 3 to 5%. Speed is 100 to 200 meters per minute, and the pavement is 240 mesh. And the correlation between FPS wear test and the tire wear test, you see a decent correlation in spite of the narrow range that I tested. So you can also find optimum conditions for heavy-duty truck tires in the paper. And that's all I have. Thank you for your attention.
Thank you very much, Mr. Hiroshi-san. I appreciate the contribution on the paper. It's a very useful paper for the tire industries. I'm sure that I encourage all the audience to go to the rubberworld.com to read. You can download this magazine. Actually, it's a free digital edition. Is a free to subscribe, and you can download it and you can read this full paper on the optimized laboratory test condition to predict tire tread wear. Thank you very much, Hiroshi-san. Before I let you go, because you are with 40 plus years in the tire industry, I'd like to ask you whether you can give some advice to the younger generation who wants to enter into the tire industry, how to be there, how to sustain, in the tire industry, please.
Oh, there's a lot of up and downs during the long time.
Yeah.
So you just have to be patient and not, stay there as long as you can. And then you learn something.
Right.
Maybe that's the way to go.
That's the way to go. And also, you also, a lot of changes happening on the EV and electric vehicles are coming in. So what kind of research is developing towards a tire design? Like to give some input on it? And because you've been there 40 years, I'd like to utilize this opportunity to give some insights on the electric vehicle development. I think it's all world is, exploding into the EVs. Yeah. So, yeah.
Well, electric vehicle, you don't have an engine. It's driven by a motor. So it's very silent. And the tire noise is going to be the main contributor for the overall noise. And I'm not sure if you want to reduce tire noise further, because you don't want a car that's approaching silently. You want to know that the car is approaching as a pedestrian. So I don't know if this is a requirement, but obviously the car manufacturers are asking to reduce noise. And tire rolling resistance and tire wear resistance, they will emphasize more in the future.
Okay.
Is that okay?
That's fine. Thank you very much. Thank you very much. Once again, I thank you for joining this session today, and I'm hoping to invite you in more sessions in the near future as it fits to you, as convenient to all of us. Yeah. Thank you very much. Yeah.
You're welcome, and thank you.
So, guys, that's the the rubber industry other talk. The topic on the optimize the optimize the laboratory test condition to predict a tire treadway. I do recommend all of you to go to the rubberworld.com. You can download the this paper if you're interested in this subject.